Good afternoon, everybody. I hope you are keeping well, and welcome to the last of a series of the Disruptive Technology Tuesdays in the Distinct project. My name is Jose Manuel Sanemeterio, and I'm the project leader of the project that is funded by the Northern Periphery and Arctic. And in this project, what the partners participating, Umeå University in Sweden, Karela University of Applied Sciences in Finland, and ourselves at ERNACT in the northwest part of Ireland, what we are trying to do is to explore the possibilities that disruptive technologies offer. In this case, disruptive technologies, we refer to disruptive technologies to the technologies of artificial intelligence, Internet of Things, and virtual reality and augmented reality, and its application in the provision of public services. In particular, we are focusing in three main areas. One is environment. The second one is health and healthcare and social care. And the final one is education and training. And again, this is the last of the series of these workshops. And we are going to focus in today in applications in education and training. We have an agenda, a pack agenda with where we will start with three presentations. Then we will have a break. And then after that, we will have also time for discussion. If you have questions, you can also have questions between presentations, or if not, you can keep them for the final part, okay? It is planned that this meeting will last for about 1 hour and a half. So let's start with the first presentation. Our first presenter is Alan Whiteside. Alan Whiteside is a community lead for medicine and life sciences at Edify, with more than 20 years of experiences in developing and adopting healthcare innovation in Scotland. Alan is going to present us a solution that uses virtual reality for accessible, immersive, and engaging educational experiences. It's a platform that is run by a company called Edify, and is a digital learning platform that combines gaming, tech, virtual reality, and user-generated content to enable accessible, immersive, and engaging educational experiences. Hello, Alan, and welcome.
Thanks, Jose Manuel. I'd like to start beginning to thank you and your colleagues at ERNACT for this opportunity to present, and your distinct partners for identifying the potential for enabling technologies to have greater impact in remote and rural communities than in urban. As Jose Manuel said, my name is Alan Whiteside, and I'm community lead at a Scottish startup called Edify. We've developed a digital learning platform that combines video conferencing, gaming technology, and virtuality. I live in the north of Scotland, where I previously worked as an innovation consultant within the National Health Service in the Highlands of Scotland. This previous work predominantly focused on Interreg projects. That was when the UK was a member state and we knew which programmes were eligible to participate in. And coincidentally, my areas of interest focused on cross-sectoral applications for enabling technology in remote and rural regions. So I definitely see the need for Distinct and the potential for enabling technologies to disrupt public sector education, training, and services. Next slide, please, Jose Manuel. The project that kickstarted my interest in collaborative innovation and sustainable rural communities was an Interreg project in the North Sea region called SHINE, which focused on new sustainable models for healthcare delivery. This introduced me to two fundamental initiatives that informed my approach to sustainable rural communities. The first was the quadruple helix for collaborative innovation between business, academia, the public sector, and the public. And the second was the smart specialisation strategy. This resulted in NHS Highland developing collaborative cross-sectoral collaborations through the SHINE project, based around the global green and healthy hospital agenda from healthcare without harm that focused on health and environment. And I'll talk a little bit more about that later. Next slide, please. As I mentioned previously, enabling technology is the key to addressing the most significant issues affecting public services, commercial services, and social development in rural communities, which are often linked to the UN Sustainable Development Goals. I met Chris Bryson, who's the man in the top left of your screen, who's now one of the directors of Edify at a digital health workshop, and we excited each other about the potential for mixed reality in healthcare. We developed the mantra VR for learning and AR for doing, and these discussions led to a fact-finding trip to China and Taiwan to find out more about both AR and VR. Separately, a collaboration with Scotland's Innovation Centre for Sensing and IoT identified both clinical and non-clinical IoT applications within hospitals and within communities, and developed infrastructure that supported wider improvement in public sector services by having a LoRaWAN network. I've not been involved in AI and blockchain projects, but certainly see its potential in extracting value from historical public sector data, optimizing the deluge of additional data that enabling technologies will create, and gaining insights that Lucas and I were discussing to disrupt public sector services that are not humanly imaginable. Next slide, please. The fundamental driver is to develop a sustainable development model that balances society, the environment, and the economy. This would be a cyclical model underpinned by skills, education, and training to ensure high-quality public sector services and academic expertise in educating the next generation. Also allow undertaking research and development innovation that focused on local issues and opportunities within rural communities, and also allow innovative SMEs driven by social and economic impact to be generated within communities. And the whole concept would be a network of collaborative communities in rural communities that could share knowledge, products, and services. Next slide, please. Digital learning platforms that allow public service organisations to train their service staff, their technical staff, collaborate with local and SMEs, and additionally support the learning and adoption of enabling technologies and the disruptive applications that are created by companies in other rural clusters. The smart specialisation model allows us to prioritise niches within key sectors where we have regional expertise that address significant issues and or opportunities within our region, and create knowledge, products, and services that are both essential and desirable in other rural communities. A particular opportunity within the NPA region and other rural regions is cross-sectoral innovation. I've included some illustrative examples to demonstrate these synergies between NPA regions, but also the potential to differentiate regions and to make them experts in addressing particular aspects of socio-economic development, climate change, sustainable communities, and other relevant areas. As I mentioned earlier, I've included some of the information about the Global Green and Healthy Hospitals agenda, which illustrates NHS Highlands' interest in areas such as pharmaceutical pollution, local food supply chains, and smart local energy systems that show the potential for cross-sectoral collaboration in rural communities. I'm keen to hear about cross-sectoral collaborations in other regions of the NPA during our discussions later. Next slide, please. One of my final projects for NHS Highland illustrates the opportunity to develop a local focus that has international potential. Tested looks at developing IoT test beds at hospitals and health centres, and the project is across the Highlands of Scotland, Northern Ireland, and coincidentally, Mikael and Vasterbotten in Sweden. The focus is on non-clinical, so expands the potential for cross-sectoral collaboration and some of the opportunities that were on the previous slide. And with the LoRaWAN network having a range up to 10 kilometres, it gives an awful lot of scope. Testbed offers great local opportunities for skills education and training within a wide variety of public sector services, but also across industry, academia, and the public. It can also facilitate research and development to address local issues and opportunities, and is a catalyst for collaborative innovation and supports regional, national, and international rollout of enabling technology solutions. Next slide, please. Applications for augmented reality support two conflicting models of public sector service delivery. The centralised model of remote experts providing generic training, maintenance, and services for a variety of public sectors and to a variety of rural communities, de-skilling the local workforce, or the alternative, a decentralized model of remote experts exchanging knowledge, products and services across a variety of public sector services and a variety of rural communities that upskills local public sector staff and contractors who can then perform the function without ongoing external mentoring, and in addition can train colleagues and other local stakeholders so that upskills the local workforce. Offering both VR and AR together is a powerful combination for rural communities of VR for learning and AR for doing. As I mentioned earlier, Edify combines gaming technology and virtual reality to create virtual environments for shared immersive first-person learning. The platform was further developed during lockdown so that virtual presentations can be broadcast over Teams and Zoom to large audiences for a third-person experience. The novelty with the Edify platform is that existing teaching materials, such as videos and PowerPoints, can be incorporated into the platform to flexibly deliver remote skills education and training. And our initial areas of focus are health and care, construction and the built environment, and tourism and culture. Can you play the video, please, Jose Manuel?
Sorry, Alan, it's not allowing me to play the video.
No, that's no problem at all. I'll send you a link in the break so that people can see what the platform's like. Just move on to the next slide. Cheers. Remote access to skills, education and training creates opportunities for disruptive models of recruitment and retention of public sector staff, particularly in rural communities. Public sector organisations can determine specific knowledge and skill sets for both current and future staff, and employees can identify courses based on their interest and desired career progression. These resources may be available through their local cluster, accessed through partnerships with other rural clusters, or a combination of royalty-free or paid-for materials and courses that they can access online. This will support the recruitment of local young people to local jobs without the need to relocate for education and risk that they don't return. Additionally, continuing professional development allows for career progression, and mentoring and supervising colleagues supports retention of existing staff. Next slide, please. This offers exciting opportunities to disrupt the traditional issues of migration for education and employment by being part of a scaled adoption of enabling technologies that additionally supports relocating to rural locations by offering quality education, good job prospects, and excellent public sector services. Learning is a critical component of the solution as it can allow people to develop their interests and passions, learn new skills and knowledge that they can share with colleagues and students, research local issues and opportunities, and develop and validate new knowledge, products and services that improves our quality of life, addresses sustainable development, and makes our rural communities attractive places to live, work and visit. Next slide, please. This model is scalable to other sectors and offers similar opportunities. Having a collaborative approach can improve the impact of shared issues and opportunities, such as having a variety of well-paid and fulfilling jobs across different sectors that would encourage a family to relocate with parents working in different industries and considering education and future employment opportunities for their children and the public sector quality for the whole family. Next slide, please. Enabling technologies have the potential to address the traditional chronic and significant issues in remote and rural communities. What was once a Herculean task to address, such as managing multi-morbidities in an aging, sparsely populated community, can be addressed by remote education, smart devices, and artificial intelligence. The solutions that our remote communities develop are scalable and not just to other rural communities. Knowledge and solutions that mitigate the need for a 30-mile, 2-hour home visit on a remote island have a similar appeal for a 4-mile, 30-minute home visit in a city during rush hour. Next slide, please. Remote learning and education creates a potential to address historical issues of migration and quality of life metrics, particularly access to healthcare and education, career progression, and public services. Disruptive innovation is led by the public sector in rural communities, and cross-sectoral clusters have the greatest potential for local impact to create models for rural sustainable development that links knowledge, products, and services between rural communities locally, regionally, nationally, and internationally. Thank you for your time, and I look forward to questions and discussions. Thank you.
Thank you, Alan, for this presentation. I think some of the comments or some of the reflections and parts of your presentation are very relevant to the DISTINCT. As you know, we are exploring the use of these technologies to cope, in particular, with the challenges that remote areas, like the common ones that we have in the Northern Periphery and Arctic, to cope with or to address the challenges that delivering public services in that rural areas or those remote areas is a real challenge, and we need to try to explore more the use of these technologies. If you have that link to the video, we can maybe play it afterwards. Yeah. If you can put that in the chat, maybe we can do it afterwards or after the break. Now I'm going to give the floor to our second presenter. In this case, will be one of our partners from Umeå University, Ulf Hedestig. Ulf works as a senior lecturer at the Department of Informatics at Umeå University and has participated in several projects like the one that he's going to present at Northern Municipality, where they tested the implementation of a LoRa network of IoT sensors that they were using for different purposes. In his presentation, you will see that he's going to present the concept of co-production by using not only or involving the stakeholders, but also using data-driven services, using data as a way of co-producing better and more responsive services. So Ulf, thank you, and the screen is yours.
Yeah, thank you very much. You almost gave the whole background for the project. I will talk about how we try to use the sensor technology in the schools or in the educational settings, and as you said, this was part of a little bigger project, and I will start to make some comments around the reason why we was doing this experiment, and the background was to look closer to the fancy words around co-production or citizen-centric movement, where you try to involve the citizens in designing new services, and usually we are seeing ways of using co-production in a setting like crowdsourcing. So you have open innovation or crowdsourcing, where you invite the citizen to participate in development in a municipality, for instance. But more and more, we can also see we have other types of settings that are usually called passive, and social media monitoring is one example of how you can get information of behavior or attitudes among citizens, and as an option to more active crowdsourcing. But the problem has always been with the co-production, and the partners we had in the project had also the same challenges, and it's connected to the crowd. When you invite the citizen to a meeting, you want to have the diversity and the difference. You have big, you think about age, gender, and equity, for instance, and usually you don't get that kind of diversity, and you don't also know how they will participate in that. And then if you don't want to have a crowd source with physical meeting, like now when we have Corona, what kind of channels or what kind of media do you want to use in that setting? So it has been challenges when we talk about citizen-centric, and in our case, we started to see if we can use IoT as an alternative for crowdsourcing, and start to see if it's possible to use more data-driven analytics to give some feedback to stakeholders, and have that as a base and a starting point for making discussions about better services or so on. So what we were doing was to see if we could implement sensors in a municipality and use the sensor to navigate their behavior in such as in that place. And the reason was that we wanted to see if it was possible by the data improve the services that was given by this municipality, if they could improve their services by this kind of data analytics. And it was also a base for looking if it was possible to even develop the business process in the municipality, and in this case in the school environment, and also if it could be improvement, if we could show data, try to visualize so the data was comprehensive and easy to understand. So what we was doing was that we apply this IoT approach in a municipality, a very little municipality. I think it's around 4,000 inhabitants in this municipality. So we put 2 base stations and created a LoRa network. So we covered the whole city by these 2 base stations, and then we tested different kinds of sensor in this setting. So we was putting up the sensors in besides the school, in the city hall, the youth center, the public bath, even the cross-country ski area was also covered with sensors. And in the school case, we was focusing on sound and noise sensors in 4 classrooms to measure the loudness within the classroom. And we put also these sound sensors in the school restaurants, and according to the kindergarten, there was an activity arena. So the attempt was to provide these data from the sound sensors so they could be as a discussion between different stakeholders. And the stakeholders in this setting was teacher, pupils, parents, principal, and the politicians. So this is the activity arena besides the kindergarten, where we put motion sensors to see where exactly the children was playing and where they were in the arena. In the school case, we tried different kinds of visualizations. So this is an example of a heat map where you can show the sound levels in a special area. But in our case, we tried to measure within the classroom during a period of 10 minutes, we measured the average sound level and the peak level. And the reason was to see if it's a very high level of sound in the classroom, if it was the reason around why perhaps it was a high level, it could be connected to sound contra the pedagogical method I have chosen, or was it dependent on the topic? If the mathematics lecture was higher level of sound than in, for instance, in biology, or if it was connected to topics, if it was sound level versus time of the day or the week, sound versus gender, sound versus age, and sound versus the working environment. Because in Sweden we have a government, the Swedish Work Environment Authority has a recommendation for teacher that the normal sound level should be 35 decibel, and it's very low level. So when we try to express and visualize the decibel level in the classroom, it was difficult to use the decibel number, because the children doesn't know what 50 decibel was. So what we tried to do was to make symbols instead of showing just 70 decibel, so they could imagine what kind of level of the noise was. So this symbols was used to describe the level of the sound level in each classrooms. So during a week, you could see the level of the noise in the classrooms, and according to this visualization, we could see the peak sound was around 90 decibel, and it's quite high. And the average was always over the recommended 35. So the intention was that we could use this kind of data to show either between the teacher and the student, the pupils, how they can lower the level of the sound in the classroom, and discuss the reasons why the level was so high in different classrooms. One of the problems was, though, that when we started to use this kind of data and show them for different stakeholders, it was a new thing in a school setting to start to discuss the sound level and connect it to education. Most of you higher up in the hierarchy you came, for instance, among the principals or the head of education in the municipality, was very keen on discussing the building and how you could emphasize and make the better ventilations or look at the furniture and so on. But the teacher and perhaps the parents was more keen on the pedagogical aspects. So that was a thing when we started to discuss this, that they had different purpose of using the data. And the challenge we could see also in using this kind of technology for a pedagogical reason is that it's, even if we use the data from the sound level or movement in the motion sensor, is that you need to require more qualitative analysis as well, because you don't know why are they moving or why is the sound. You need qualitative data also, and discuss and interpret this kind of data. And we could also see that the sensor, these black boxes you find, was destroyed in some of the areas, and that connects much to the privacy issue, and also is the problem of how to visualize the sensor data. That's a key also, because different stakeholders in this case interpret data in different ways. And that was my presentation.
Thank you, Ulf, for the presentation. Maybe I have a question, just curiosity, because I really like that slide where you were trying to find out if there are correlations between the sound levels and different topics. Did you get any conclusion or any particular thing that maybe you could share with us?
Yeah, we asked the teachers to try to see if there was differences, because they actually, before they started to use these sensors, many of the teacher was aware about the high level in the classroom, so they had on their mobile phone a mobile app that measured the decibel. So they was actually afraid of, because some of the teachers had tinnitus, for instance. So they was quite afraid of this, and sometimes they said that of course when they have music, for instance, then it was quite high level of in the classrooms, but some of them did not understand why, because they had not imagined the sound level so high. So, but they didn't actually go so through why they looked at the topics. I think that they made that in the first week and tried to see if there was a correlation between when they had mathematics or language, for instance. But they had not so much to measure around. And we just used it as an experiment, so we didn't go so much further into the educational aspects of using the sensors. But it could have been very interesting to see. Especially would I have been interested to look at pedagogical models, for instance, if you is more problem-based, or if you're more have another types of learning styles, how it affect the levels in the classroom.
Thank you, Ulf. I see that there is a question from Margaret. She's saying in the chat that she wonders if you could comment if there was an interest or feasibility in using some sensors for assessing the ventilation in classroom settings, given the current crisis, given the current situation with COVID-19, where the classrooms have to be more ventilated. So,
yeah, because that was one of the problems also. We could because when we started to look at the sound levels, and when there was no one in the room, we could see that two of the classrooms had higher level of sound, and that was due to the ventilation system in these two classrooms that was higher. So it was more efficient ventilation in that two rooms instead of the other two, because there the ventilation system was I don't know why but it provided not so much air as in the other two, and that we recognized by the sound sensors, for instance. So that was recognized when we saw that there was differences in the starting level.
Thank you, Ulf. I don't see any other question for you. I see that there is a previous question from Rika to Alan, but maybe we are going to take that after Lucas' presentation, if you don't mind, Rika. So then we move into the last presentation. The last presentation is going to be made by Dr. Lucas Porwall, that he's the e-government unit leader at the Insight Center for Data Analytics, belonging to the National University of Ireland, Galway. His research focuses on leveraging digital technologies such as virtual reality and artificial intelligence to support effective communication through better engagement, collaboration, and co-creation, and in particular in the context of highly interactive e-participation experiences and media convergence. Lucas is going to present us the use of virtual reality and artificial intelligence for the next generation of type of training experiences. So Lucas,
yes, thank you. Thank you,
the screen is
Manuel.
yours. I will share your presentation.
I'll just wait for sharing. Okay. So hello everybody. Thank you, Jose Manuel, for this kind line of introduction. Yeah, so my name is Dr. Lucas Porwell, and I represent Insight Center for Data Analytics. Yeah, you can see my alias here. Look, yeah, that's usually the name I use in my contacts with my American partners, with growing collaborations on the other side of the Atlantic. So yeah, we can go to the next slide. My journey with VR started a good couple of years ago as a researcher. I believe it was more or less 2016 when I started to dive deeper into it. It was a natural continuation for my line of research, which before was focused on serious communications and emerging technologies related to communications, including social media. And as I completed my PhD, I was looking for new topics, emerging topics that would be a natural extension of serious communication, and VR came as a kind of a major topic in that domain. As mentioned, yes, it was 2016, I started to dive more into the topic, and it coincided with the increased availability of the affordable VR headsets and related technologies that emerged and made their way to consumer market at the same time. And also in terms of software, a lot of new platforms were built. Here we can see one of my first major engagements with Elsevier, which is one of the major scientific publishers in the world. So very early, actually, I've engaged with them over training in VR as part of me being an advisor for Mendeley, which is a sub-company for Elsevier. And I've been in touch with the Elsevier executives over how the knowledge business like theirs can benefit from knowledge transfer in VR. And you can see one of the fruits of that collaboration. I was invited over to headquarters in London, and we've had a lot of interesting talks there over how the knowledge can be transferred in this next generation internet, especially considering that the written word consumption is falling. So if we talk books, if we talk articles, those entities like Elsevier noted that the consumption is going down. Therefore, there is a need for exploring new ways for knowledge transfer. So is that even possible via educational training? As the article says, I believe, yeah, I have some answers to it. So we can have the next slide. So if we talk VR and education, I would like to take you on a bit of a journey here through some of our projects. Of course, this first engagement with Elsevier was really informative, and then we went into practical applications, how we can approach the VR in education. And one of the things that came up, and I have this nice picture of tools there, because you need a tool set, a solid tool set to even start doing anything. One of the things is to have up-to-date VR hardware. I've mentioned that a couple of years ago, a lot of new solutions emerged, affordable solutions. Before, VR was kind of a niche in the defense, in the medical sector. So where there were money to put on these expensive devices. Now VR made it into consumer market. Very affordable solutions are currently available. However, this space is progressing very fast, which is good, but also the drawback is that the hardware becomes obsolete. Within 2 or 3 years, the hardware can be quite useless. So one of the things we faced through our experimentation was that, yeah, keeping up-to-date hardware is quite essential in order to perform. Another thing is also to make sure that the infrastructure, like broadband and wireless infrastructure, is updated as well, so that the connectivity is strong and uninterrupted. This is absolutely pivotal for any kind of online experience, as we know, whether it's Zoom or any other online communication, but so much more also in VR. Then you need some kind of a software platform to run your VR education on. And the very first platforms were social VR platforms, but now we also have dedicated, more professional platforms, and I'll elaborate about them a bit further. And you need some digital educational assets. So as you know from online e-learning, that's not a new thing. However, some of it has to be updated or adapted to this third dimension. So you could also have three-dimensional objects and spatial presentations. Finally, I could say it's final, but it's last not the least, is the fact that you need consent from schools, and you need some champion to kind of support your endeavors in terms of VR and education. Because of the novelty of those platforms, there isn't much policy from the school or schools in terms of how to engage in VR and how to allow pupils to use it. So definitely you need kind of a champion, whether it's a principal or teacher, to step in and take the responsibility for using those technologies. As of now, there is very little guidance in terms of education, but also ethical consideration. And this is also a field that we try to explore actively in my line of research. Can I have a next slide, please? So in terms of hardware, that is actually a complex issue here. I think there is no competition when it comes to Oculus Quest 2, which is delivered by Facebook, or now Meta. It's absolutely the best in terms of what you get for the price, and the price is actually a mid-range phone. So that's quite affordable considering how advanced the technology is. And you also need good wireless. The conflict that might appear sometimes is that some schools have blocked social media on their wireless networks for various reasons. So like, yeah, Facebook might not be available, and so are like Oculus services. And that can cause some issues. Some schools also have policy not to use products by social media companies, which can introduce some issues. So far, we were quite good in that regard, but I know that for some entities, that might be a major obstacle. But in terms of hardware availability, it's there and it's very affordable already. And we can only see the prices dropping as the technology progresses. Can I have a next slide? In terms of software platforms, we've used, I mentioned that it all started with, let's say, kind of social VR, more informal communication platforms. Now we can see a bit more specialization in the field. So we have tools which are oriented towards professional stakeholder. However, that wasn't the case a couple of years ago when we started. And we started with social VR, so what was out there and was solid enough to proceed. And we started in particular with Outspace VR, which is a platform now owned by Microsoft and developed further. That was one of the very first social VR, which was very efficient with a vibrant community of users. And it's a quite flexible framework to use for all kind of VR presentations. So that was our first, let's say, first choice in terms of engaging in VR with schools. A second tool we've used was Mozilla Hubs, which is an open source WebXR standard-based solution by Mozilla Foundation. So it's open, it's very available, if I may say. It's free. However, that comes at some price in terms of performance, and also it's not as visually appealing maybe as Outspace VR and similar platforms. But for various reasons that I will explain in a second, we use those two. Later, you can see again more specialized platforms like Spatial, or ones offered by Facebook Meta like Horizon. And Horizon has now actually two offerings already. One is Horizon Worlds, which is currently only available in America and Canada, and also Horizon Workrooms, which is explicitly designed for work. And this platform is probably the most advanced platform in the market now in terms of what you can do in VR. Okay, so can we move forward? How did we start to engage with schools? That started way before pandemics. So you can see we started with in-person engagements and visits from school to our institute at Insight Center for Data Analytics. And you can see here, pupils wearing our headsets and engaging using Outspace VR platform. That kind of engagement was easier to set up, considering the hardware, software. But then, of course, pandemics happen, and we had to go fully remote. And you can move to the next slide. We had to go, fully virtual, and we would lend headsets to schools, but we would no longer be in the same room with students, and we would be fully in full remote setting. And what you can see here is one of our first the VR classroom sessions. So as far as I know, we were the pioneer in Ireland, and maybe one of the first in Europe, if not in the world, to do full VR classroom. The way it worked, we have a researcher presenting their research to students, encouraging them to to take on the STEM field, to join the team of scientists, right, in the future. And so that would be a direct knowledge transfer from researchers presenting their findings or their research in a very friendly way to students, so they can understand and engage with the content. And the students learn, can have conversation with the presenter. And then we had several extra, let's say, elements to the engagement. The venue was constructed that it had, as you can see in the pictures, we have a lecture hall where the main presentation was. In the back, in the balcony, we had a poster session. You can see a fragment of a poster on climate change research, where students could read those posters, discuss it with author. And finally, we had a lobby called Data Muses Lobby, which is another initiative from us, where we try to bridge arts and data, so visualizing data using art. And students could also engage with works from researchers, and of course, also try to engage over the results presented there. So that was our base setup, and we've run it with several schools. This way with secondary schools. And that resulted in some publications in the press. And I think that was quite pioneering work that turned out to be working quite fine, despite the challenges, of course, in terms of delivering the headsets. So ideally, everybody would have a headset at home. However, at this stage, we had to deliver them. One of the, okay, I have a question here. So, okay, I will answer that later, maybe, Margaret. I wanted to go back to the presentations and the availability hardware. I mentioned that before. During our engagements, our hardware became deprecated or obsolete. So the very first headsets we used were Oculus Go, which were the first affordable headsets from Oculus, standalone headsets. And unfortunately, the support for these headsets have been expired. So we had to renew our headset line. Also, the solutions like Outspace VR became more computationally heavy, so those headsets could not perform well enough, and the support was also removed from them. So that's kind of an obstacle that appeared at some stage, basically hardware aging. And again, that's something you have to be up to date, and can be has to be a factor to something to factor in. Okay, can we have the next slide? So I mentioned we engage in Outspace VR using VR headsets. So all both researcher and presenter and students, everybody was wearing a virtual reality headset that was exclusive. So everybody was immersed. But then we realized we also would like to try to engage with primary schools. the issue that you may have with engaging with primary school is quite, it's on the legal side and also, let's say, health and safety. Those headsets, all the VR headsets are now recommended to be used with age 13 and above. So that's the official message you see on the box. So technically, you should not use it with individuals below the age of 13. And because there is no studies that would, confirm or ensure that this is safe for children. So so we had to use different means of engaging, and for that we decided to use a Mozilla Hubs platform, which is open source. First of all, it's available online, but also allows you to interact with the system regardless whether you use a mobile phone, whether you use a desktop machine, or whether you use a VR headset. So you can, anything with a browser, you can engage with through that platform, and it's fairly easy to use. You just get the link and you get inside the room. And that was quite a success. We've engaged with primary schools. Kids were really happy with what we've done. We recreated a real location, which is Computers and Communications Museum of Ireland, that we host at Insight Center, and we created a virtual representation of that space where children could learn about the history of computing. And we also had additional venues attached to it with portals so children could explore. We also worked with communities like hacker programming communities, like we organized Back to Basics session where children from the age, I think we had participants from the age of 8 until 80, so older children engaged into programming, and we used the virtual reality space for that community. Okay, we can move forward. So what you see here is a continuation. Basically, what I wanted to stress here is that there is attached venue to the museum. With the portal, we go to a treasure hunt venue. And that was quite innovative approach here because what I did is I created a pipeline where I can recreate any location in the world, physical location inside a VR space. So what you see in the right bottom corner is the visualization of Connemara National Park, especially Diamond Hill. So that's based on maps, GIS, and elevation data from NASA. And through automated pipeline, we can create pretty much anywhere in the world. We can recreate landscape. So that's what we did, and we also augmented this place with some extra elements, like you can see visual elements like trees, rainbows, attractive to children, and we had a treasure hunt. So there were elements hidden throughout this new world created, and they were related to Irish history and some kind of Irish national symbols as well. And children could explore and learn. So there was a double kind of impact here, tacit learning, and through very unique engagement. So yeah, that worked really, really well. And I think that was a quite interesting way of have more informal learning, where especially during pandemics, where children often were confined to their household, with remote learning could actually go into virtual outside and engage with their friends in the Connemara Park and roam around and learn something. So that was quite innovative. But in this case, we did not use virtual reality headsets. I did, and presenters did. However, children, if they were under the age, they just engaged through browser for health and safety and regulation reasons. Okay, can we have the next slide? And that leads me to another more recent engagement. So also during pandemics, and I've engaged with various research groups, especially in Boston, and through our collaboration with Simmons University, we've expanded to MIT and Harvard University. And thanks to those engagements and our strong contribution, I was nominated to co-chair a Reality Fest, which is MIT Reality Hack spin-off, where we organized a hacker event entirely in VR. My responsibilities included, of course, management of the event, but also I designed the venues that you see there, and that was driven by our research to provide efficient communication in VR. Very interesting event, gathering top students, developers, and business people coming over and hacking in terms of XR technologies. You can see actually in the right bottom, we have Timmy Girau from Volvo actually presenting their work in XR. Volvo is a very big player in terms of XR and VR, and Timmy is a great example how XR and automotive industry can bridge together. He's presenting there. We have people from fashion industry in the middle presenting. We got a lot of presenters from fashion and XR. So there is a growing group of people interested in XR. And you can see this also was type of, you can say, educational training engagement, because we had hackers learning about things, presenters. So we've used the knowledge we gathered from past experiences, and we pushed it forward beyond, let's say, classroom, and also to more professional setting. And that was very successful. Here again, we use Altspace VR platform and customly designed venues. Okay, next slide. So what fed to that MIT Reality Hack and Reality Fest was actually this project, just called VR Dialogue. That was funded by European Commission as part of Next Generation Internet Explorers program, where I engaged with the US entity, Simmons University, and on a research expedition. That coincided with pandemics. I could not travel to United States initially, so we've collaborated remotely. But in November, I finally managed, as soon as the border was opened, I traveled to United States for a month, and we've collaborated there. Also, through all extended collaboration with MIT and Harvard, we've designed an AI-driven lens for studying communication XR. That's how we call it. It's basically a platform based on Mozilla Hubs, where we are able to gather data, from engagements in VR. We can have multiple groups simultaneously engaging on our platform, and we gather data in terms of gazing, in terms of position, in terms of hand movement, using virtual tools, voice level. So we don't record voice, again, for ethical and privacy reasons, but we can estimate, the level of voice, which may indicate that somebody is, shouting. I think something that was in the past presentation in terms of measuring noise in the room, that's in virtual. What was very important about that approach is that it's very affordable. It's in the cloud because it's hosted online, does not require any installation. We use Amazon services to host it. It runs 24/7, and anybody can perform research sessions. So the cost is hosting here, and we have dashboards, analytic dashboards that provide also live data, and we provide post-event processing and analytics, and it's driven by AI. So the project was oriented towards identifying behavioral patterns, and it's also ongoing research how AI can learn in different settings, whether we have a presentation, conversation, collaboration, and identify specific behavioral patterns, and we try to understand better what's going on in those engagements. So as far as we know, this is one of the first platforms that allow group study behavior without the need for specialized headsets, like, with eye tracking, face tracking. We just use standard headsets, and we get the data of telemetrics coming to the server, and we try to make sense of it. So it's very accessible to researchers in this sense. As we know, it can be a barrier to acquire those expensive headsets, those specialist headsets with extra sensors. We try to make up with the good results through different methodology. We look at, as I say, telemetric data and group behavior with a significant level of success. And we hope this will help us to understand better what's happening. So for instance, AI can detect, ideally could detect who is focused, who is not, at what time, which content was interesting, which wasn't, which place was the most visited. So you could generate heat maps and see how people engaged in different moments of the presentation or engagement. From interesting findings we learned already on this quite, let's say, tentative research that we conveyed is that, for instance, position was more important than any other factor, more important than gazing, more important than voice, to distinguish different type of behavior. So based on position alone and the dynamics of the position, the AI was able to determine very well what's going on with position alone, when we would have expectation that gazing or voice would have a bigger role. So yeah, there is an interesting things that AI can see we can't, and that's what the project is about. And we hope to push it forward through different grants that we've applied now too. Okay, so that's the use of AI here. And maybe the last slide, because I think I'm going a bit over time now. I've presented that to Jose Manuel and the group in other engagement. So there is a new let's say framework from OpenAI initiative called GPT-3, and that goes beyond of what we've seen with VR Dialogue. That goes into using AI to actually engage with people. So you have I won't present here the video, but I can provide the link later in the break as well. So you have artificial avatars that can answer pretty much any question, any question at all, because the knowledge base is based on millions and billions of connections, logical connections gathered from the internet. Very impressive framework. Does not always respond ideally, but is able to answer pretty any question, which is very impressive. And that's probably a future of education as well, to have virtual tutors that can analyze everything you did in the past and offer you the best tutoring experience. So that's probably something where we are headed at some stage. But this is the future. This is still something not, let's say, well checked and well analyzed, but it's very impressive if you just see what's already available there. That's something definitely to consider. And if I can go back again to VR Dialogue, I just want to say that we believe this grassroots of framework we've created, it's already quite impressive, because as I said, like we can analyze behavior in VR and can use it to analyze a lot of social issues, not only the VR communication, but more deeper communication aspects, such as now through our collaboration with partners from US and also Israel. We look at, for instance, biases, conscious and unconscious biases, whether it is in terms of ethnicity, race, gender, and we look whether, so we try to study, for instance, if biases from real world somehow map to VR, and if they do, is there any way to alleviate those? And as we know, unconscious bias does not have to be harmful, but can impact communication in some way. So we want to see, how affinity or other reactions can actually impact communication. And that actually, again, goes beyond VR. It allows us to study behavior, which normal setting, you would need a room with a lot of cameras and sensors, but because we have a VR environment, we have all the data we want, we own the matrix, we can get a lot of interesting data. So potential of this research goes beyond VR and can have some applications in real life engagements. So our VR and AI in education, let's say, framework now goes towards training models over different types of engagements in VR, training related to education, training and business engagements. And we try to identify patterns that support or hinder efficient communication. So that's the ultimate goal, to provide, let's say, a live dashboard for teacher or presenter that helps the person to understand better what's going on in the room and receive more feedback, which will be kind of visual. So whether showing a heat map on the floor or marking some people that maybe require extra engagement, they might be losing focus, as well as providing more comprehensive reports at the end that will help to evaluate the engagement from various different perspectives. And yeah, AI is of great help here to crunch all these massive amounts of data that are generated by the headsets themselves. So to give you like kind of an approximation, we were collecting like one engagement would be like 1 hour engagement could generate almost 1 gigabyte per headset of data without compression if we fit it all. So we had to do a lot of optimization in terms of network and then what is sent, what isn't, because with the engagement of 25 people, you have already 25 gigabytes of data per 1 hour engagement. So it's an absolute mine of data that could be used for anything, and only AI to help you to comprehend it. So yeah, I would like to finish here because I think that will be the last slide. And thank you very much.
Thank you very much, Lucas. I think it has been a really good presentation, very visual with a lot of examples. I see actually that you have created a lot of interest because there are several questions in the chat. I want to suggest one thing. It was supposed that we were having a break 10 minutes ago. So what I suggest is maybe we continue. Before going into the questions, maybe Lucas and Alan, there are some questions for you. You can check them in the chat. And while you are checking them, and then we will go through them, I'm just going to play that video that was sent from Alan. That is 1 minute and a half video. And then we go back to the questions and to the discussions, because I think it's better now to go through this rather than having a 10 minutes break, and then we can maybe finish earlier, if you don't mind. Okay, so I'm going to share the video.
Edify helps students learn without limits via the power of immersive technology. Edify lets educators create virtual lessons from a library of subject-specific content. Gaming tech, combined with video conferencing, enables accessible and engaging educational experiences remotely.
Excuse me, can you show me that again, please?
Yes, of course, I'll do that for you now. Is that clearer for you?
Unlimited access to million-dollar labs. Store and publish lessons so students can learn in their own time, again and again. Make the impossible possible with immersive technologies integrated into standard video calling tools from anywhere, on any device. Personalized learning through data-driven insights. Designed by academics, for academics. This is remote, immersive education. This is Edify.
Okay, thanks for the video, Alan. So yeah, I think maybe we can go through the questions that we still have in the chat. Let's start with the first one that came from Alan's presentation from Rika. Question for Alan is, what have been the main challenge issues with getting the end users, customers to use remote solutions, or have they been openly adopted? Alan?
I think the answer to that one, Rika, is threefold. One's to do with Edify. We have a background in providing VR environments for customers. So we've got an office in Scotland, but an office in the Middle East in Dubai that serves the UAE and Saudi. And so we're used to kind of delivering for a particular client, and we needed to get the idea that we're not just doing it for one client, we're building a platform that should be scalable and universal and used by others. Two other factors about the adoption was when we're looking at, if I use healthcare as an example, the people who have traditionally been involved, universities and healthcare providers, it's not building a faster horse and car, it's building a motor engine where they're taking the courses that they now run and just sticking them in VR. We need to develop new models, so it's taking a bit of time to build that up to see how you incorporate traditional resources and VR in order to develop new ways and disruptive ways of delivering education skills and training. And the third and a critical part is the policy and decision makers. So if I use an example, we'd have all been familiar with this being an NPA project of the bridging call. I was part of a consortium that got turned down because it didn't see the need for the platform and a demand. And that's interesting when you look, for example, with Canada joining. Canada currently has 300,000 nurses and a shortfall of 60,000. Now we're working with University of Saskatchewan to apply for funding within Canada to look at VR for mental health education. And that's across a network of decentralized universities in Canada looking to address that. And interestingly, they are part of a network known as the Northern Nursing Education Network, which involves Iceland, Greenland, Sweden, Finland, that's looking at this as well. And often we call it your neighbours up in Nordbotten at Luleå are members of that. But interestingly, we look at it from a Finnish perspective. Finland has a proposed crisis in 2030 of a shortfall of 30,000 nurses with our current 80,000 nurses. Now you can see how with the requirement to speak Finnish, that's going to be an issue in terms of recruiting non-Finnish nurses, and that's just going to be exacerbated in rural communities. So I think it's how we get all the stakeholders together in order to come up with new models that address these issues. But yeah, it's how we do these things kind of collectively, and particularly in the NPA, come up with solutions that work. For example, where students in Scotland could be attending a lecture in Finland or Canada, it's how we go about developing new models that allow remote access both to students, trainees, and substantive healthcare professionals that are in posts.
Thank you, Alan. Maybe have more questions here. One from Margaret. Maybe I'm going to direct this to you, Lucas. Mm-hmm. Are there any studies that show that tech such as VR give improved learning outcomes, or is it too early for this?
So I think it's a very good question that not only educators or people in education sectors put, but also all other industries is how much VR is, nice and flashy, and how much it actually solves anything, And that's a question that is not yet well answered. We see now dozens, if not hundreds, of platforms for VR collaboration. So there is this funny colloquial saying in the domain saying that everybody's uncle has a social VR network now, because there is so many platforms that, grew up like mushrooms now last year, of course, fueled by pandemics. But, how much value is there and how much it can actually improve the learning experience? Is to be answered. And that's one part of the reason why actually we did apply for this grant for VR Dialogue to create a platform to study basically what happens in VR and, what is people's reaction to it and how do they behave. And based on that, to have a data-driven research, because of course we can do surveys and ask people how do they feel, but we want to have more comprehensive study where we combine it with data, actual data from the system to see whether any specific behavior happens or not, and see whether there is a specific contribution if you use specific VR tool. Because if we talk VR, it's again a massive field, a lot of different solution, different environment, different experience. So we want to be quite granular in terms of what specific collaboration tools work. Virtual dashboards, virtual whiteboards, 3D models. It's all very flashy and looks nice, but does it add anything? If I put a double helix, is it easy to use, or it's easier just to do it, in 2D? So these are questions we try to answer. So there is no good answer as of now, but that's a very good field to be in, to see, and that's also part of my industrial collaboration. The financial sector also wonders, is it just a hoax, or is it a buzz, or is there something behind it that can help us to improve our business? And so there's a whole study that will be devoted to it. Yeah.
Thanks, Lucas. I was actually thinking about the inspiration you can get when you can actually, if you're studying biology or the heart and the, insects, and you can actually shrink down to their level and really understand what's going on, more than the the actual platform and the tools. But I guess, yeah, that would take quite a lot of work to figure that kind of thing out.
Margaret, you actually tackle something very, very important, which is the experience. And that was actually, so yeah, in November during my expedition, I also went to California for Augmented World Expo, which is like the largest event for VR, XR in the world. And there is a lot of, it's kind of business and developer oriented. So it was very interesting to see where the business and industry is at the moment. And the head of data visualization and innovation from Microsoft said something important. He said, like, we approach VR and 3D from the very bad perspective, at least a lot of solutions. We try to say, have what we have, which is Excel sheets and charts, and put them in 3D. And that should do the magic. He said, no, it's not the way. It's not the way to use the third dimension. In VR, as you said, you can use the effect of scale, the effect of experience. So as you say, if you make yourself as small as a mouse and you are right next to it, it gives you a very different perspective than you just see it on the screen, whether it's 3D or not, it doesn't matter. You actually try to play with different variables, which are related to human cognition and perception. So we observe things by comparison. So scale matters, experience of that matters, and also we are driven by storytelling. So if you can present a story, so again, I think massive area for arts and data, representation. How do you create a specific experience in people so that they can make a better decision or better comprehend or remember what they look at? Yeah.
Thanks, Lucas.
Thank you.
Okay. Talking about experience, actually, there is a question coming from Rika for you, Lucas, that is coming from personal experience about the time of using the virtual reality headsets or glasses for more than 30 minutes, that she's getting bad headaches. So she's asking if there were differences in the classrooms tests and how secondary school students accepted the VR classrooms, and if there are difficulties with the students, for example, using the headsets, like, for example, having issues with like headaches or
we've been very careful, again, because we were pioneering, right? So we made the very strong guidelines saying that as soon as you feel uneasy or a bit sick, please just take off the headset and relax and breathe, and please discontinue as soon as you feel any kind of a symptom. However, the experience showed that it was very rare, at least among students, to react in a bad way. So since I run it with students and older cohorts, it seems like older individuals actually suffer more. And maybe that's just because, I don't know, the brains of the youngsters are already used to, a lot of fast changing content and so on, but they apparently deal way better. So even my niece, who has a strong locomotion sickness and so on, she doesn't react at all in VR. She can stay there for hours. So I feel like there is some distinction. Yeah, youngsters suffer less. Scientifically looking at it, the reaction that we have is basically because it's related actually to hardware. So the better the hardware, the less the effect. And of course, the hardware is improving every year, so you will see less and less of that effect. The major contributor to sickness is the delay between the vision and movement. So if the device cannot perform visually fast enough and the frame rate drops, and there is a disparity between also sensors, movement sensors. If you move your head and your vision is following slower, even fraction of second, that can, of course, depends on the individual trigger the sickness. And the reason is your brain thinks you ingested a poison, and like you were drunk or something, and your vision is desynchronized with the rest of the signals your body receives. So the natural reaction is you want to remove the poison, right? Because you've been poisoned. So that's at the individual level, and people react differently to this stimuli. Youngsters seem to react much less. In older groups, maybe I had like 2 cases where a person became just a bit sick, but not much. Yeah, as I see a huge improvement in terms of hardware. So this effect will be less and less. And that was actually the major obstacle for the consumer market VR headsets. They were not released until they at least try to solve it. So there is a whole industry working 24/7 to making sure that those effects are the least. And with every generation, it's better. So if I can make a basic recommendation, again, I put it in my presentation, up-to-date hardware. And there is one reason is, of course, performance in being able to use the latest experiences, but also the newer it is, the less likely you have to have those effects and problems.
Thank you, Lucas. Maybe we can go for a final question that is about, also coming from Rika, about how do you see the ethical side of AI working as a tutor? If it uses all the information from the internet, or how do you see regulations aiding in giving factual or peer review information instead of just the top results from the internet?
So I don't know if it's to me as well.
Yeah, that goes, well, yeah. I think that,
yeah,
that goes to you, but can also be taken from other representatives if you want, but yeah, maybe.
So I may try to be very brief because maybe somebody else, I don't want to monopolize here the conversation.
No problem.
So yeah, there is certain limitation here. Definitely, if we talk about this newest solution, I try to talk at the very end. Yeah, that might be a bit risky in terms of this thing, but being connected to everything, it can answer in a bit unpredictable way. So I think maybe more confined solutions that are more rule-based will be more welcome in the educational sector, where the risk is less, that the system can, come up with something which you don't really want. So a kind of trained solutions which are more in specific domain, and something which could be like evolution of our VR dialogue, where you would train it on specific corpus of data so that it won't go beyond that, so something what we also did with Jose Manuel in terms of chatbots. So you have specific corpus and you train this AI over this so that you avoid any kind of unwelcome results, and if it's history or geography or whatever, that could be the same, rather than going to Wikipedia, which can be correct and might not, dependable how people edited it. You would rather use established sources and train your AI or whatever technology you use over that specific corpus. And I think that's something that definitely should be the case in terms of education.
Thank you, Lucas. Well, I think if there are no other questions, I think we are coming to the end. Yeah, I would like maybe the presenters to switch on your cameras. And of course, I want to thank you for your presentations. Very interesting. I think we have tackled a very new topic with a lot of potential. Actually, I was reflecting on some of your recommendations, Lucas, at the very beginning. We see that virtual reality, for example, has a lot of potential to deliver services or to deliver skills in remote areas like the NPA and the type of project that we are in Distinct. But of course, there are a lot of implications. Skills is also one of the main topics that are coming to the agendas to every region, city, local authority or country. So we see that that the potential is there, but there are a lot of factors that we have to take into consideration. At the moment, actually, we are working in some implementation roadmaps to implement this type of solutions in the regions participating in these teams. So I was also taking very good notes about the implications. Yeah, I just last words is that I hope that the people attending found that interesting. The event, as you know, has been recorded, so we will be also publicizing and making that accessible. So in case you know people that could be interested in this topic, please feel free to share it with them. This is all from my side. Once again, thank you very much, and see you next time.